Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Mojan. Hi, Fred.
Hey, Mojan. Good talking to you again. Hey, I heard you ran into a dilemma type question or something of interest. You mentioned it briefly the other day.
Yes. One of my friends and previous colleagues was mentioning to me that I was asking him, hey, what are you thinking? What are you working on these days? What's on your mind? And he was saying that in his field, he's working on these devices that obviously need to be reliable. They're in the electronics world.
Okay.
And uptime for this product is very important. However, they will also be once they're in the field, they will have an agreement with, whoever's their customer, that there will be a service plan that the customer basically will be paying for. So there would be some preventative maintenance that would be done basically. So you could have some replacements done basically in the field over the life of this product. And so he was asking me, he's like, well, now I have to think about, how do I think about the fact that there will be some replacements that I can do, or repairs, if you will, depending on, how they look at it. Because he has always been used to, the product has a life of X number of years, and it needs to be reliable to, X% for this number of years. And that's the target that he's used. And that's how he's gone about, the design and the testing and everything. So he's like, but now I have this bonus is I think how he was thinking about it, where he's buying extra life, right, in a way. And so he was like, well, how do I guess he's not buying, he's getting paid for extra life. And so his thought was, do I take credit for this extra, for this repair that I'm going to get paid for in my reliability target planning? And how do I go about doing that? And I thought that was a good topic for us to kind of chat about, because I think a lot of people probably for their products think about what that means and how, if uptime and availability especially is an important metric. I think it's a fair question to be kind of thinking about.
It is. And I've run into this a handful of times. The closest one, and we got reminded about it being a useful feature last night, is we had a power outage locally for, 10, 15 minutes, but our whole house generator kicked in. And so just about everything in the house was working again. And the generator, when I bought it years ago, they offered a service plan with it. And it was, I don't know, it seemed expensive. So I got a hold of a third party and he says, oh no, we can do it half as often, which is twice as much as it needs, and you'll be fine. And I said, well, how do you know that? And he says, I work in this county in the mountains where you live, and I've serviced these other generators, and the use conditions is not the worst case. It's not corroding. You're not against the coast. You're not using it full time to power your house off the grid. So you don't need to change the oil every 3 months. So the folks that created or designed the generator and sold it to me based their time-based maintenance plan and service plan on worst case rather than use case. And it does track and report hours out. So I said, when it goes 1,000 hours, then we need to do an oil change. And that might take 6 months. So 1 year it did. And other times it might take 5 years. And oil doesn't like just sitting there either. It oxidizes and breaks down somewhere. So there's a trade-off with any of them. But I use that story is that the idea would be with your friend is in the model, it only works if it's an item that is a predictable wear of some sort based on use or time or whatever the failure mechanism is. Think of brake pads on a car, right? You can wait until they start squealing at you and then replace them, or you could replace it slightly before that. But it doesn't make sense to replace the brake pads every 3 months. It'd be really expensive and probably cause more damage to your wheels than not doing all those repairs.
Mm.
But just because you can do the maintenance doesn't mean you should. It really depends on what are the failure mechanisms. And if it's a big electronics box of some sort, it might be cleaning filters and diagnosing the torque on, say, heat sinks, if there's things like that, or double checking the connectors that they haven't vibrated loose or, open or something like that. The cleanup and maintenance things then can be adjusted depending on where in the world they are. If they're in a very dusty environment, the filter cleaning may be more frequent, where if they're in a high corrosion area, other types of steps may be taken to keep it running. So it's those kinds of things, the maintenance that repairs or replaces things that are worn out, restart them back to zero. But you need to know it's going to do that before you can model it. So it really starts with the mechanism in which environments you're expected to be in and use cases. And then it gets complicated after that. But going in and inspecting is really hard to model unless you know what you're looking for. It's like, if we're getting this corrosion on these boards, all right, I got to replace it before it fails. Okay. But you got to know it's going to be corrosion. And depending on the environment, it may occur sooner than later. And then you set your inspection frequency
Mhm.
accordingly.
Which is where then your design for reliability work comes in to understand, what are the failure modes, what are the failure mechanisms from there,
Hmm.
and then
Hmm.
figure out, can you model them or not, and then figure out the likelihood of those occurring based on your use conditions, and then to your point, then you can perhaps take those into account in terms of what your service plan really should be based on, because you don't want to kind of say, yeah, this is going to cover everything, but you can kind of set the frequency based on, maybe the first thing that's going to go, or what's depending on your, to your point, like geographical distribution,
Hmm.
etc. Right? That's kind of where you're getting at.
Yeah. And one other client I worked with, and I know I mentioned these guys before, is it was I mean, an amazingly high 5 nines wasn't even that was
Mm-hmm.
totally unacceptable availability for this system. And it was, you just lose count of how many nines it had in that kind of metric. But whenever they had an issue and they had 3 levels of redundancy, if one board didn't agree with the other 2 boards, they'd swap that board out, and they could do it hot swap. So the system would still function and operate with 2 boards, say the IO boards they were using. Um, and the swap only took a few minutes. So they would have spares on site, and a flag would go off saying this goes. They'd have a local technician that could deal with it. That would alert the home mothership basically, and they get the board back, do diagnostics, failure analysis, everything else. And it was all covered under the plan. They were leasing basically the equipment to this facility, and they were operating it and maintaining it. So every time they had a failure, it cost them money. And so they were very interested in improving the reliability of their systems because it was coming right out off the top of their profit.
Mm-hmm.
And
Do they in that case they I miss another thing that you mentioned is it sounds like they were monitoring, right? So that's
mhm,
where another factor that can really be informative in figuring out how to what's going on basically in your device in the field can
yeah.
be the signals that you're getting back from in-service conditions.
Oh yeah, yeah. No, I worked with one. It was an inverter for a large solar field array kind of thing, and the heart of this thing was this component called an IGBT, which I
Mm-hmm.
really don't understand what that stood for, but it was the thing that changed the DC to AC, and it got hot, and so there's this massive heat sink spreader thing on it, and it was all management of heat, so this thing would stay in an operating cozy temperature. And as that ability to transfer heat out changed, they were monitoring that. And they could tell it's sort of like a bearing. Once it starts to rattle or it has a little bit different vibration type signals, you know that something's wrong.
Mm-hmm.
before it actually fails. And that's what they were doing, is they were monitoring the the decrease in the I want to say extruded temperature, the transferred temperature out, because they knew it was running and it should be 100 C at this point. And if it's only at 90 C, then something in that heat transfer path is not working or degrading. And then they say, all right, we got to go change out this heat sink system on here, or this component, before it failed. And it was, you're right. It's again, though, it's, and when I say again, though, it sounds like Kirk. I have to be careful with that. Is you really have to understand the failure mechanism, because you can measure all kinds of stuff, but if you don't know what that really means and
Mm-hmm.
what you need to do about it, and then you're replacing everything in the board, and why don't you just make the whole thing a whole field replaceable unit, replace the whole computer and put a new one back in, which may be the right choice for uptime. Make the replacement, the diagnostics and replacement very fast. Where
Mm-hmm.
if it's more, yeah, I get 8 hours of shut or downtime because the sun's not shining, then I can do more diagnostic work. I can figure out what the right part is. I don't have to make it super fast to change. And then I can focus on changing the parts that really matter versus the whole thing. And there are always trade-offs every single run you get into, but taking credit for it in a model is, I use the brakes as the example. If you can monitor the brake wear based on actual use of that vehicle, which is now possible, some of the telemetry that's coming out, you
Mm-hmm.
know within a couple of weeks when that brake is done and when that chance of it's
Mm-hmm.
fracturing or not working is really high, and then you swap it out. You don't waste any of the brake pad. It you don't artificially do it when it still has 2 years left on it, things like that. And it costs less, it's less disruptive, on and on and on. If you don't monitor it, then it's, wait for the wear pad to start squealing at you. Just kind of dangerous.
Yes, yes. You know, the one thing that I have consistently, unfortunately, noticed is that in cases like this, is that by the time usually the company or team starts to think about, okay, how do I what do I need to know in order to know if, the issue is coming up? Like, what's my
Hmm.
detection?
Right.
At that point, usually the design is done. The
And we have no
software
more
is
power allocation. The cable's not big enough.
exactly. There's no packaging availability. The computers on the system are
Maxed
at
out.
max capacity. So, adding more sensors, not to mention the packaging challenge with the sensors, but even just the compute power required for, the additional
Hmm.
information that the computers would be processing is challenging. And then not to mention the upload of the data to the cloud and
Yeah.
processing. And so
It's got to be really
it
worth it.
happens. It's got to be worth it. And I think, like, the key thing, the key takeaway that I always tell people, especially if I'm, talking to them early on, is design it in now. Like, really think about what detections you want to have based on the failure mechanisms, and think about it now, because the longer you wait, the harder it will be and the more expensive it will be to try and make changes, and it will make it so much harder to get the information that you need. And sometimes you can't, and you just kind of have to make major assumptions that you're kind of going in blind and you don't really know. So you have to make major
Hmm.
assumptions. So the earlier you can think about these things, the better, because it will save a lot of headache and money and just time that is spent to try and kind of, you know, um, figure out what's going on with your product, basically, in terms of usage, and be able to predict issues.
Yeah, it's getting easier and easier though. The ability to have a Wi-Fi total system on a chip basically is there. You don't need special antennas. You don't. There's. I mean, it's still a challenge when it's in an area that doesn't have Wi-Fi signals or cell service or. Uh, but I mean, we're getting new in our neighborhood. We're getting new water meters, and they have I think it's Bluetooth. There might be some other, but it's a short range communication system. So the person reading the meters just has to be within about 10 feet of it, and can be driving if the box is within 10 feet of the road. And as opposed to finding each meter, fending off the dogs and squirrels and opening the meter and reading it
Yes.
kind of thing.
Yes.
We have big squirrels here.
I just kind of pictured yeah, I just kind of pictured this. What does this look like fending off the squirrels?
Yeah, you don't have that many squirrels there then, I guess.
No, I guess we don't.
Yeah. But the idea is that in that case, the technology of whatever that communication system is, the short range system, got small enough and cheap enough and low power density enough that what they actually do is they bundle those packages into a hermetically sealed case, essentially. You can't replace the batteries. You replace the whole unit. And the units get replaced when it's no longer able to be calibrated. And the power goes much longer than it's needed for that to occur. Which is back to our last episode on paper jam problems. But
Hmm.
the
Hmm.
idea is that our technology is getting better and smaller and cheaper. Yet even with that, if you don't start with the design up front, taking that into account,
Yes.
then you're kind of, well, run it to failure and hope for the best.
Yeah.
And
Or I mean, it just becomes harder, right? Like
it
to just
does.
do it later is harder.
Yeah.
Yeah.
Well, back to this question though, is part of it too. I mean, to me, it's all to what's the failure mechanisms? What is it they're there
Yes.
to
Yeah.
maintain or inspect or monitor or whatever? It's not like we're going to send a tech out and just kind of look at it and hope it's working. And if anything's obvious, then like a squirrel is in there, do that.
Hmm.
And in that case, I have no idea how to model that benefit of the inspection. The inspection has to be for something. It could be for corrosion, it could be for cable connections, it could be for cleaning the filters of an air, moving system, putting a sensor on it or a scope on it to see if the bearings on the fans are solid still or not, or is temperatures are different. Use an IR camera and scan the circuit board looking for hot spots. It's a sign of
Hmm.
trouble. But when it's a random inspection like that, it's really hard to take proactively during the design phase, say, oh, we get a benefit for that. Well, okay, how much? For what? You know?
Hmm.
And,
Yes. Yes. Yes.
and the other side of it is more you really benefit from censoring up your system, especially if it's a remote system, to give you a lot of telemetry so that you roll a truck out there only when it's needed.
Hmm.
If it's in
Exactly.
the building
Yeah.
next to you, you walk over there and check it out every couple of days. You're just a part of the family now. Whereas if it's way out in the middle of nowhere, it costs a lot of money to roll a tech team out there. And if there's nothing for them to really do, it's a wasted roll.
Hmm.
And if it's the system is down, well, now they're down while they drive out there. It's the downtime is extended. So what are the trade-offs? What's most important? If availability is most important, then it's replace the whole thing every year if you can afford it. If if availability is that important, have redundant systems, on and on and on. There's always options, but they all have costs. They're all trade-offs.
Yeah. It's basically like you have different knobs to turn. So it's a matter of like which one gives you the most benefit for the cost that you're incurring as a result of it.
That's right. Now,
Yeah.
when you get, I'm going to use the car brake one because I think most of us can deal with that one, is that I'll throw my ex-wife under the brakes there. She drove like a bus driver. It was either full speed or full stop. It was crazy how she drove. But the brakes would wear really fast because she was
Hmm.
hard braking a lot. It's kind of scary. I always chose to drive. So if somebody is driving like that, the brakes will wear out way faster. And so what Detroit and automakers do in general is say, well, what's the worst case? And we have a fallback if the wear pad or the little squealing sound that comes out of it, loud squealing sound. Um, but we'll say, inspect the brakes every service interval, for example,
Hmm.
whatever it is. And
Yeah.
it's just
Yeah.
looking at what's the state of wear. And that would catch because it's a 2-minute inspection, well, it's not that they charge you for 40 minutes, but they, um, you inspect it and you can tell, yeah, it's worn or it's not. And, and then you can recommend a replacement or not. So if the inspection is clear, it's not ambiguous, whatever that word is. Um,
Ambiguous.
yeah,
Yes.
that's easy for you to say. Right?
Yes.
Then
Yeah.
the inspection might be the right option.
And if it's accessible, right? To your point
Right.
earlier, like is it easy to get there or get the device to an inspector or get the inspector to the device? But if
Yeah.
it's not, then it's of course it's a lot harder. I This makes me think about pipelines. I used to work
Hmm.
on steel pipes, welding of pipes, and I'm a metallurgist, so um,
The
I
weld
worked
quality
on
type
the
stuff.
yeah, exactly, the weld quality of these. I think they were called spiral webs because they would have spiral welds on them.
Hmm.
And they uh, it was the same. Like as I was working on those, like in undergrad, I was always thinking about like, okay, these things go out in the middle of nowhere, and they're
Hmm.
super long, right? And because they have, they're transferring natural gas or whatever they're transferring in them from obviously probably between provinces in Canada. This was in Canada. So, and we would have these inspection. Sometimes it would be like robotic inspections on the, whether it was like ultrasonic or, it could be obviously manual inspections on the welds.
Hmm.
Um, and, these are like very long pipes. So obviously the welds are also super long. And so you can imagine just how long it would take to inspect these things over time. And so, of course, they're going to corrode eventually, right, in the field.
Right.
And my thought at the time was always, like how, and they would send people out, right? So back then it would be that somebody would be going out into the field and doing inspections every so often. And
Yeah.
they probably had, I think at the time they had like, whatever device, whether it was a phased array or something that they had that they would be inspecting, they would record the readings or whatever, whatever they were measuring, if it was
Hmm.
measurement, they would record the readings on paper, so by hand. And then they
Yep.
would go back to, their office. Then they would transcribe what they wrote down into an Excel sheet, on their computer.
Hmm.
And all of this, we're assuming no errors are happening here.
Oh,
And
of
so,
course. Of
of
course.
course. And then these, obviously these intervals were just kind of set, in a not necessarily based on in a smart way, right? Like these were just intervals that were just set. And so I just like at the time I remember thinking, I'm like, I bet this is going to be one of the first things to be automated because it's got to be cheaper to have just sensors on the pipes, that you're monitoring and you can tell uh, just remotely using telemetry, whether what's going on with the pipes and whether you need to go check it out or not.
Yeah.
And that would be a lot cheaper. I wonder if that's happening now. If anyone if anyone listening is working in the oil and gas or heavy industry and of these, I would love to learn if that's now the case.
Yeah. And then back to the point of
Yeah.
the question today is if you know about an efficient way to model the upside to doing inspections or maintenance or predictive maintenance or seen anything related to that, that'd be really cool to get some hands on that and some more
Hmm.
insights on it.
Yeah.
Yeah, I love what we do. We got so many different things we could
Yes,
stick our fingers
yes,
into them. We could,
I agree. There's such fun problems, in my opinion.
yeah, they
I
are.
think it's so cool. Yes,
Yeah.
yes, I
And
agree.
then at the end of the day, we get to break things and go, oh, that was fun. Why did
Yes,
that happen?
yes,
Let's go
yes.
fix that.
Yes. I every time I'm reminded of when I'm talking to someone and I realize that they're like breaking things is not like they're, the thing that's
Passion in
foremost in
life.
their, yeah, exactly, passion in life. I just kind of get reminded of, oh yeah, not everyone thinks this. Huh. Okay. Right. 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 I just kind of forget because I think it's so fun because I feel like that's what everybody wants to do, but apparently not.
Yeah, no, apparently not. And one of the solace of that is that next time you see somebody, calling their partner at an airport for a pickup and the phone just works.
Mm-hmm.
That's the result of a whole lot of reliability and quality people and design teams making it happen. And
Oh,
that's what it's
many teams.
supposed to
Yeah.
do, right? And that's
Mm-hmm.
what people have learned is that it just works.
Yes.
And
Yes.
so you just count on it. And that doesn't happen by chance. So it's thanks to folks like you, Mojan, that just make things like that happen. Now you got to
And
work on those.
yourself.
Well, yeah, but you got to work on those oil pipes. They explode every now and then, those natural gas pipes.
Oh God. Yeah.
That
No,
kind of thing.
definitely. Yeah. Those need to improve. Yes.
All right.
Yes.
So
Yes.
anyway, if you got some ideas or comments or questions or a whole nother topic, whatever, or a question facing yourself, let us know. We'll get you an answer back or try to, and or at least some ideas or things to think about. And more likely than not, we'll probably talk about it on an upcoming episode. That's what we really like. That's why I keep asking. Head over to accendoreliability.com/go/SOR and find a couple of ways to get in touch with us. Rajan and I and the other hosts are available through our LinkedIn profiles and our about pages on Accendo. So plenty of ways for you to get in touch. And we look forward to hearing from you. So,
Yeah, absolutely. Thank you so much, Fred.
all right.
This was great.
Yeah, good. And we'll talk to you soon. Take care.
Yeah, thank you. You too.
Yeah, bye-bye. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.